Newton has three laws of motion: inertia, acceleration, and equal and opposite forces. Newton's first law explains that an object that is stationary will stay stationary until an outside force is acted upon it, and that an object that is moving will keep the same velocity until an outside force is acted upon it. Newton's second law explains that the force applied on an object is equal to the object's mass times by the acceleration. The more force applied on an object, the more acceleration it will experience, and the lighter an object is, less force is required to move the object. The force applied to an object is the net force of all four forces. For example, if an object's thrust is 10 newtons right and its drag is 5 newtons left, you would subtract 5 from 10, giving you a net force of 5 newtons right. Newton's third law states that every action has an equal and opposite reaction. For example, if you drop a ball at 5 kilometers an hour, it will hit the ground, then the force of the ball will exert into the ground, and the ground will exert the same force back into the ball, causing it to bounce back up at 5 kilometers an hour.
With no force acting upon it, an object that is stationary will tend to stay stationary, but an object in motion will tend to stay in motion, and they'll sustain the same velocity and the same inertia until a force acts upon it.
Here you can see the ball is stationary, and the ball stays stationary until it is kicked. Then the ball stays at a constant velocity until it hits an unbalanced force. In this example, the unbalanced force is the fence.
The acceleration of an object is dependent upon the net force acting upon the object and the mass of the object.
Here you can see that the lighter ball goes a lot further and a lot quicker than the heavier ball when acted upon by a similar net force.
The law of action says, for every action, there is an equal and opposite reaction.
Here you can see that the force from a movement exerts into each other's hands and then back again, causing us to be pushed backwards.